Hi, my name's Craig. In this video, I'm going to go through question 1e of the 2014 Physics, Earth and Space Science, 2024 exam on the Physics, Earth and Space Science Level 1. So I'll just skip down to the question and we'll get straight into it. It's to do with energy. In this case here, it says Janet's friend Maya retrieves the ball from the ground and runs up 2 flights of stairs covering a total height of 15 meters. Maya has a mass of 48 kg. She takes 34.2 seconds to reach the top. Let's calculate the power. That requires using your calculator, unless you can do the math in your head. And begin your answer by describing the meaning of power and how it relates to her running up the stairs. State any assumptions you make, include a unit within your answer. You should always be including units anyway. So let's discuss describe what power is. Power is the amount of energy used over time. And how did I know that? Well, you can always refer to your equations that you were given in the exam. So when you're doing these physics assessments, and if you do physics later on as well, you want to try and, as much as possible, use the equations to tell you what your definitions are. In this case here, these are the equations you get in your resource sheet. And notice how there's only a couple in here that we'll actually end up using for this question. Let me also do what you're supposed to do in the question as well. We've got a height. I'm highlighting or outlining the parts of the question that you'll probably need to use, okay? Because you get given numbers. It's always about numbers in physics. So you've got the mass, we've got a height or change in height. Either way is fine. And then we've also got a time as well, so in T, so it's just seconds one. So seconds, mass of kg, and feel free to, you can draw over your exam. There's no law against it. Go for it. It's your exam. I think you're just not allowed to draw inside the examiner's little box there, I think. Yeah. Does it actually say? Sometimes it says you're not supposed to draw in there. Anyway, doesn't matter. So we've already described the meaning of power, so that's been done. Power is the amount of energy used over time, and I'm using this equation here rearranged into P delta E over time. So notice that the very definition of power is in the formula itself. Okay, so I'm just using the formula. Power is, that equal sign is saying is. Power is the amount of energy or energy used over time. It's very simple. So just sometimes if you just look at your formulas and you go, oh, I can make a sentence out of that, there you go, you're done. Now, how does it relate to her running up the stairs? Now, in this case, she's using energy to get up the stairs. And so what we could say is using kinetic energy to move up the stairs. That energy is being stored in gravitational potential energy. There's a change in energy there. She's using kinetic energy, her movement energy, to go up the stairs and storing that as gravitational potential energy. Cool. All right. Assumptions that we're making. The assumption is in this question is the opposite to the one above, where we know that in all instances, pretty much every single instance of energy change, there's always going to be loss, and that loss is generally heat energy. 99% of the time, you're losing a little bit of energy to heat energy in some way, and that's usually due to friction. But in this case here, we're going to assume that she's not losing any energy so that we can calculate power, or at least make a good estimation of it. So assuming that no energy is being lost to heat, all of the gravitational or kinetic energy is being converted into gravitational potential energy. Okay, because we don't know how fast she's going, so we can't calculate her kinetic energy. We do know her mass, but we can't but we don't know. We can't use this equation because we don't know her velocity. What is her velocity? Don't know, so we can't use that equation. We can partly use this equation to work out the work, so you could use that one. The equivalent is what I'm going to be using is this one. We're not doing a thermal one. This one's to do with electricity, so it can't be this one. We're going to use the gravitational constant in that equation. Nothing to do with thermal. Again, nothing to do with electricity for this equation, so we don't need those equations for this one. Q. Okay, so that being said, gravitational potential energy gained, so because we need to calculate how much energy, and then from there we can work out, using the time, we can work out how much power she was generating. Gravitational potential energy gained equals, her mass was 48, was it? Yep, 48 kg. And it has to be in kilograms. If it's in grams, you need to convert it to kilograms. 48 kg times 10, so that's the gravitational constant, 10, times the height, which was 15 meters. Yep, 15. And so we get, in terms of joules or energy, it's 7,200 joules. We haven't answered the question yet because we're supposed to calculate the power, so we're almost there. And we just go power equals change in energy over time. Change in energy we just worked out was 7,200 joules. That's how much joules of kinetic energy is being converted into gravitational potential energy, assuming we're not losing anything to heat, which there would be in reality, but this is a good estimation. And she takes 34.2 seconds to get up the stairs. Seconds, so that's joules second, but the measurement of power is in watts, that's your units, and so 7,200 divided by that, 34.2, a pen over there, 210 watts approximately, 3SF. Let's go, can I erase and rewrite, and then I'll go, you're supposed to put the 3SF behind the units, and so that's your wattage. Oh, sorry, I think in 3SF that's actually 211. Go away. And so that's question 1E of that exam, and that'll get you to, getting all those points gets you up to the excellence level. Cool.